Hi, welcome to today's webinar, 9 Ways Multi-Jet 3D Printing Delivers Superior RP Versatility. So my name is Sam Green. I'm the Global Category Manager for the professional line of 3D printers here at 3D Systems. I've been involved in the additive manufacturing industry for about 10 years now, and I've worked in a number of the largest 3D printing system vendors in the industry. So to start our discussion, we first will need to define a few things. So what do we mean when we say versatility? Well, the versatility of a 3D printer can be measured by many factors, or even all of them together. For example, material variety, the properties of those materials, the strengths, the temperature resistance, the speed of the printer, the build volume, ease of use, fidelity, which means the representation of the final product that you're trying to eventually create. Post-processing, how easy is it? Surface quality of the parts, the resolution of your printer, and the operating environment that the printer works in, whether it requires a special setup, whether it's green, whether it's user-friendly. All of these factors together really determine versatility in terms of 3D printing. So now that we've defined versatility, what are those 9 ways that MJP technology delivers it? Well, I think first of all, MJP technology is able to reproduce the finest design details. We're constantly innovating in terms of materials, which enables us to open up constantly new applications to the market. We're able to create moving assemblies out of the printer. We're able to lightweight otherwise heavy rigid parts. We can simulate glass and PMMA with clear transparency. We can functionally simulate snap fits and hinges. The parts and the materials are suitable for creating a large range of jigs and fixtures. We can create many full-scale parts, but in an office footprint solution. And of course the speed, which is very high speed, and availability, which is 24/7. So let's dive into each one of these separately. What is it about MJP technology that delivers the finest design details? Well, first of all, MJP technology stands for multi-jet printing, which, as you may already know, uses inkjet printheads to jet an acrylic-based resin that's cured by UV light on the build tray. This technology is known for its very high fidelity, which means the representation or the realism of the final product. Fidelity is a function of surface quality of the part and also of accuracy and resolution. But it turns out that even more important than the raw resolution is the chemistry and the process that the printer uses. MJP technology uses proprietary thermally controlled materials. As each heated droplet of material is jetted, it immediately cools and holds its shape as it lands on the build tray. The result is that the printed material doesn't ooze over the edges or pool in the corners. So the edges are 90 degrees sharp, the holes are round, the corners are clean, and sidewalls have excellent surface quality. Now combine that information to the fact that we have a very high resolution. The Project MJP 2500 system prints at a resolution of 800 by 900 by 790 dpi. So just for comparison, the limit of the human retina is just 300 dpi. You're also printing at 32 micron layers. Now overall, that means that we're printing 568 million droplets of material per cubic inch. And you can see the results in these pictures here. The top 2 pictures represent the Project MJP 2500 Plus system, which is producing a water jet. And as you can see, these triangular holes are sharp, they're crisp, and as a result, you see the water jet nozzle in its functional test. The water actually comes out smooth and straight and sharp. Whereas using other jetting technologies, in the bottom 2 pictures, you can see those angles don't fully come out in the printing process. And as a result, the water jet, when it's functionally tested, does not come out smooth. Those lines are not separate and the water tends to overlap and skew. Now, the next factor that's often overlooked, but that's really critical, is support. This is where jetting technology really differs from other technologies such as SLA. Jetting technology allows you to separately jet a model material and then a different support material rather than the same material for model and support, which means that you have to then cut those support structures off somehow. MJP technology takes this advantage even a step further. Not only is the support material a different material, but it's been optimized for really easy and fast removal. For bulk support removal, you simply place the parts in our finisher oven or the Easy Clean steamer system, and then the remaining support wax is easily dissolved away using a hands-free automated process in either an ultrasonic bath or using our Easy Clean system, heated at 65 degrees. You can use either mineral oil with a few drops of dish soap or the Easy Rinse solution with water, and then those support waxes quickly and easily dissolve away in a very green process. So this process takes care of the very fine details of the part. And because we're not using heavy chemical-based solvents or high-pressure water jets, like you see in the bottom photo here, there's no damage or deformation to the model, and there's no residual support material left trapped in the cavities. So you see in the MJP picture at the top here, those holes on this water filtration device turn out really clean and nice. There is no support material trapped inside that cavity. Whereas in the bottom box, you can see that yellow support material still trapped inside, and there has been deformation caused by the water jet. Well, the water jet would typically break those fine print details, and the chemical bath would maybe deform those walls, as you can see here. And here's a typical part that I've printed, and I've actually filmed it for you. This is my own hand here. So you see the holes on this filtration device are clean of support and sharp, unlike other jetting technologies, and the curved surfaces are smooth without any stepping effects that you typically find in some technologies such as FDM, for example. So this is a nice part. Now the next point that's really critical is materials, both material range and material capabilities. And 3D Systems has really invested a lot to make the materials as functional and versatile as possible. So we have a number of great modeling materials in white, clear transparent and grey materials. These are the VisiJet M2R white, M2R clear, M2R grey. These materials feature rigid functionality, moderate flex, and a look and feel of injection molded plastics that are suitable for most common prototyping applications. They're both durable and stable under most conditions, making them ideal for visual concept modeling applications. Then we have the VisiJet M2R clear and white, which are both class 6 capable for medical, biocompatible and skin touch applications. Another great material is the VisiJet M2R tan material, which is a really high quality, high contrast material with good modulus and a heat resistance of up to 71 degrees. So that's 71 degrees C, by the way. And then we have the VisiJet M2R black, a rigid black material, which has great rigidity, low flex, as well as a high temperature resistance and a nice opaque black finish. This material is ideal for applications that need stiff dimensional performance and quite a high temperature resistance. Then we have the VisiJet M2G Clear, which is the engineering clear material or armor material. This exhibits an exceptional mix of tensile strength and flex. So it really delivers advanced prototyping performance similar to ABS materials for a variety of engineering and functional applications. Then the ProFlex, which is the M2G Dure, which is another engineering material, extremely flexible, high impact resistance, and polypropylene-like performance. This material is really good for living hinges and use cases that require durability and extreme pliability. And then we have two elastomeric materials, the elastomeric black and the elastomeric natural. All these materials are excellent for printing soft rubber-like parts such as gaskets, piping, rubber buttons, and more. So our rubber-like materials offer the best combination of pliability and strength with amazing elongation and a really good elastic memory. So in these two clips here, I've printed a couple of nice parts for you. The left part is printed in the M2R rigid black material. The part is a really nice size and it's got great dimensional performance and quite a high temperature resistance, making it a great design and functional performance prototype. But what's really great here is that the part features a functional screw thread assembly that came like this out of the printer, thanks to the soluble support and the high fidelity and resolution of the printer. The clip on the right side is printed in a tan material that we mentioned earlier, and again, it was printed as a finished assembly with smoothly working, accurately printed and fine detailed joints and hinges. Again, both these parts are ideally printed in MJP technology, both in terms of the speed to final part and the final quality of that part. Okay, so in this slide, you get the pleasure of seeing me here in person in the bottom screen. Here I am, I've printed one of my favorite parts. This is really a unique feature of MJP technology. This is a part of a commercial drone. In fact, it's the body of the drone. The designers of this part needed a technology that would be able to accurately reproduce both the propeller blades of the drone and the body. Now, jetting technology like MJP is ideal for creating those blades that need to be fine detailed and smooth. But resins are typically quite dense and denser than regular plastics, which means other jetting technologies would be unsuitable for printing the body of this drone. They would just turn out too heavy for the drone to fly. So typically they'd need a jetting system to create those blades and maybe an FDM system to create the lightweight body. However, this is where MJP technology really shines. It can really do both of these parts using the lightweighting function of our 3D Sprint software package. So among many other features of the 3D Sprint, it allows you to quickly and automatically create a sparse, hollow structure to your part, as you see in this top photo here, in this top GIF here. And with a soluble support and some cleverly located drainage holes, you can really end up with a part that's much lighter than typical. So in this case, it's 70% lighter than a fully printed part, but with almost no loss of strength. And of course, when you're using less material, you're cutting your cost per part down, in this case by up to 35%. Another important feature of MJP technology is the ability to produce really clear, transparent, yet functional parts using a choice of two different clear materials. The VisiJet M2R Clear, which as I mentioned a few slides back, is biocompatible class 6, which makes this a great choice for medical devices where you need contact with the skin or mucosal membrane, and where you need to see through the parts, such as in a surgical guide or devices where liquid or gas is flowing through the system. The second material is the VisiJet Armor. Now this is a really good functional material with a high impact resistance that makes this ideal for simulating clear transparent parts that would be assembled into a larger assembly, such as automotive lighting covers and electrical or consumer goods products. The parts can also be tinted using just regular fabric dyes to create a really nice selection of clear colored lenses, as you see in this bottom photo here. Out of the printer, the clarity can be easily achieved using lacquer, and I personally prefer sanding a variety of sandpaper grades, or even a combination of both to create a really glass-like finish to these parts. MJP technology is an excellent way to iteratively test complex and fine detailed snap fits. So stress concentrations, the stress, concentration, relaxation, and fatigue, they're all quite difficult design considerations, and they can be very constraining for most snap fit designs. So the VisiJet Armor and the ProFlex materials were specifically designed to create robust snap fits that really simulate the properties of traditional injection molded plastics, as you see in these two photos, or this photo on the right and this short clip on the left. So on the left-hand photo here, we have a printed assembly that has two printed hinges and two printed snap fits. One snap fit holds the top onto the bottom, and the other one allows the bottom half to split open, as you see in this picture. Both these snap fits are simple cantilever style snap fits with uniform geometry. Now these features work really well in both the rigid and the engineering materials. In this case, it's the rigid grey material. But the other point I want to make in this slide is the ability to machine the parts once they're out of the printer. The rigid materials that we offer are extremely versatile for when you need to drill the parts or tap holes or press fit precision dowel pins. You can add screws to to bosses, you can press fit brass inserts, as you can see in the right hand photo here, and you can machine precision holes. In addition, you can also print those screw threads. So that's the unique capability of MJP, which allows you to easily print most thread sizes, which can then be used in combination with standard threaded machine screws. This is exactly what you need when you want to create a range of jigs and fixtures. In fact, in our engineering labs, we have jigs and fixtures at every single point in those labs. They're used everywhere. And I believe that's the case in most engineering departments and design departments. Jigs and fixtures are truly vital to the product that you're making. And it's important that you can really machine these materials and parts once they're out of the printer. So some considerations and changes, of course, need to be made when using these materials for screwing and drilling. The engineering materials have the highest elongation and toughness, and that's what we recommend for most engineering applications. Just recall, and remember, when you're printing holes, make them slightly larger to reduce the hoop stress. You can add material or make walls a little bit thicker in these prototypes or jigs and fixtures so they can withstand the higher hoop loads without cracking and breaking. And of course, different screw types can create different hoop stresses. So pilot holes should often be used to reduce the cracking and breaking on some parts. Another aspect of versatility that really shines with MJP technology is the trade-off between officeability and part build volume. With the Project MJP 2500 Plus that you see in this photo here on the right, you get a build volume that's big enough for the majority of full-scale parts, especially if you're talking about a wide range of industries that are classified under consumer goods and consumer electronics, such as this drill with a 3D printed clear transparent cover here that's been machined onto a working prototype. But also the system itself, although industrial in terms of productivity and output, it only weighs 211 kilos, and its dimensions of 1,120 by 740 by 1,070 centimeters. It fits nicely into most office rooms, so it's just over 1 by 1 in the XY direction and almost a meter in terms of width. So once it's in there, it operates quietly at normal room temperatures with no offensive odors. And importantly, the post-processing of the parts requires no special installation, and it doesn't generate a messy work area that you would get with some other 3D printing technologies. So this is a great slide. We have here a stop motion comparison of the MJP 2500 Plus system on the left versus another jetting system on the right. So both have the same number and the same exact parts on the tray, yet the 2500 Plus system finishes the same job in 1/3 of the time. In fact, there are many jobs where it's just as quick or nearly as quick to produce multiple parts as it is to produce just one. And that's because the print process runs along 3 imaginary lanes, if you like, inside the build chamber. And if you're able to stack your parts or nest them nicely within a single lane, you can become far more productive on large or recurring jobs. In fact, with a print speed on the 2500 of up to 303 centimeters per hour, which is 18.5 inches cubed per hour, most practical jobs will be finished in 1 day or overnight. Add to that the time and labor that you're saving in post-processing that I described to you a little bit earlier, and the fast and easy job submission with the 3D Sprint software, and overall you're going to be extremely fast and extremely efficient. So if I could add a point that wasn't on my original list, that would bring us from 9 points to actually 10 points why MJP technology is extremely versatile. It's a word about the importance of the vendor's expertise and the vendor's experience. When purchasing a 3D printer, it's easy just to look at system specs, but the truth of the matter is the vendor's expertise and the support infrastructure they offer is critical to your overall success. So 3D Systems is a global 3D solutions company. We've got over 1,000 patents, 13 facilities worldwide, over 2,600 employees, and we have a presence in 68 countries with a very extensive partner base. So more than any other vendor, I believe, we have the experience and the expertise to be totally focused on building the most reliable 3D printers in the world and then connecting our customers with the expertise and the digital manufacturing workflow they need to really solve their business challenges. And then a final word about the future. So additive and 3D printing will continue to develop more and more, and the applications that it will be suitable for will continue to expand, especially within your industries. So as your company grows, you will need to add additional solutions and technologies. Today, there are very few vendors out there that can provide the technological breadth and depth of additive solutions to answer all of your enterprise requirements. And few can offer the software and services needed to really tie all those systems together. I'm hoping you'll find out more about 3D systems. Why not book a meeting with our friendly staff or visit us at one of our facilities, or just browse our website at the address here below, www.3dsystems.com. So thanks very much for listening and enjoy the rest of your day.